So Tyler, you were away the last couple weeks. We recorded a couple episodes ahead, so the viewers didn't miss out on some wonderful podcast experiences. But you were in Hawaii
Was in Hawaii for 2 weeks.
for 2 weeks. Did you get to enjoy any of the native flora and fauna of Hawaii?
I didn't get to enjoy anything per se. I mean, I ate some mahi-mahi. That was pretty good.
Okay, mahi mahi is delicious.
Mahi-mahi is delicious. And there were these really cool birds, and I kept meaning to, figure out what it was, but I just never did. It kind of looks like a woodpecker. Like, it's got the red cap of, not the pileated woodpecker, but, the other one. Was it, like, a red-headed woodpecker, maybe?
Okay.
It has,
Yeah, go ahead.
because it doesn't have, the crest.
It's just the red.
It just has, a red patch on his face.
Okay.
I just couldn't remember. I just never looked into it. But as much as I, badmouthed the trip, the view was immaculate outside of where I was staying.
It had to be.
Yeah.
And then you came back to the wonderful northeastern United States and snow.
Yeah, I got off my plane and it was 18 degrees.
That's
I left and it was 80.
That's fantastic. Well, welcome everybody to Life, the Complete Story. I am Alex, and this is Tyler. We are your hosts, your guides through the tree of life, your amateur biologists on a good day. But
Today was a good day.
Today was today was a very good day. Today we are talking about the Cypriniformes, which is as we continue our trek through the fish. We're going to be here a while just to let you all know. But before we get into that, we always do a little nature in the news. And today's news article comes to us from Aarhus University. It is published a few days ago. It is titled Resilient Algae May Speed Up Greenland Ice Melt. Tyler, if you want to talk a little bit about this, you can.
Yeah, so basically the rundown is, so every year the snow melts sooner and sooner in the areas that get that permafrost there, and heavy snowfall, not so much in the temperate areas, but the snow is melting sooner and sooner in the year each year, and in turn that makes these algae populate faster, so they're populating more rapidly throughout the year, which in turn makes the ice melt even faster than if they weren't there. And that is because these algae are able to consume high amounts of phosphorus. Correct, Alex?
I believe they're able to store high amounts of phosphorus. I don't think they consume it. They're still algae, but they store high amounts of phosphorus for long periods of time, which is an essential nutrient for plants, and algae or sort of plants to grow.
Right.
Yes.
So I was continuing to read. I did not get a chance to really go in depth on this article. I was busy doing research further on down the line for today. But, before we used to think that ice was pretty dead, and since it was so cold, nothing could survive on the ice. That's not true at all. There's a lot of microbial life that exists on these ice caps and stuff. So the ice algae is elongated, brownish, and ellipses shape, so it's more ovular, and they thrive on ice, hence why they're called ice algae. We found them a variety of places, Greenland ice sheets, the Alps, Himalayas, and even Alaska, and they go through photosynthesis since they're an algae, so they make the O2, the oxygen, by using that sunlight, water, and carbon dioxide. They also need a little bit of other things that just or a general upkeep for themselves rather than the actual photosynthetic process, that being that phosphorus, nitrogen, and just normal carbon. And then when we get to spring and summer, when that ice melts, typically there's these large algal blooms which make darkened ice. So
typically that shows up as a brownish black color, I think.
Yeah, and this is what's causing the Greenland ice melt to rapidize, because photosynthesis.
So as of course with climate change, and the snow is beginning to melt earlier and earlier each year, so these areas that used to be covered with snow year round are now just bare ice patches, which these algae are thriving on now that they have even better access to the sunlight, making these bigger dark areas.
Yeah. And since they can store the phosphorus, they're able to colonize areas that don't have as much phosphorus, which makes the algal patches even bigger
Yes,
over time.
and because they are that dark color, they're able to absorb more of the solar radiation, specifically the heat, and it spreads to the ice surrounding them, which then melts the ice faster, and that's where our tidal comes into play. Yeah, and of course, it's kind of a vicious cycle as more ice is melted, and eventually gets down to bare ground. You have more phosphorus available, and more of that snow is melted. It just provides more room for algae, which then, and then once you get the bare ground, that absorbs even more heat, giving that heat off to the ice surrounding it, and it just kind of is a its own destructive cycle.
Yeah, that's fun times.
Yeah, and this is something that you see globally, not just because of the algae, but this is one thing that could be contributing, even if it's in a small amount, but it could be contributing and making matters worse.
And we're not saying that this only happens in Greenland. It's just the study took place on these Greenland ice caps. So I don't want to assume, because that's never a good thing to do scientifically. But it's a pretty safe hypothesis that in those other areas I mentioned, like the Alps, like the Himalayas, like the mountains of Alaska, and even the Rockies, that this same event is happening.
Yeah.
Maybe not to as large of a scale, but similar things are happening.
Yeah. So we'll have to stay tuned for more research on this sea, because, as I said, it's fairly new research in this specific area. So a lot of this isn't something that they're going to integrate into climate models yet, but it could eventually be included, kind of helping narrow down some of that, how that ice melt is going to look in years to come, and how it'll kind of affect that climate change as a whole.
Right. Anything else to add, Alex?
I do not have anything else to add. That will lead us then into the main event, our lesson for today.
Yeah, welcome to the meat and potatoes of today's episode, everybody. As we said, we're talking Cypriniformes. So a little rundown of what that is. First of all, this is going to be probably a three-parter. So this is part one. We're going to be talking about the suckers. But this Cypriniformes are a group that contain about 12 families and over 400 genera, and over 4,000 species within that. And these are the likes of carp, gobies, loaches, bodias, and minnows, as well as the suckers. They're most diverse in Asia, and they're completely absent from the continents of... Thank you, Alex. They're completely absent from the continents of Australia and South America. Alex has so graciously pulled up a picture of a dozen or so species of various, carp, goby, sucker,
Loaches.
loach. So the longest living species, as well as the largest species, is the big mouth buffalo, and it clocks in at about 112 years old as its maximum age, which is a long time for a fish.
Yes.
Most of the time a fish lives about 6 to 12 years. Obviously, some other fish like sturgeons and the Greenland shark live a lot longer, but relatively speaking, no more than 20 years is average for a fish. Their closest relatives are the Cypriniformes, the Cypriniformes, and the Gymnotiformes. Those are all groups we have not talked about yet, but are coming in the next couple episodes. That would be like piranhas and tetras, catfish, and I'm blanking on the Gymnotiformes.
I'd have to look it up, but that is for another day.
They have a Weberian apparatus. That was our ecology encyclopedia from 2 weeks ago, and that is a apparatus that allows them to use their gas bladder in a way to breathe as well, but different than some of the other things we've talked about. Yeah, it's connects the swim bladder to the auditory system in fishes, in the Ostariophyses superorder, which is what we're talking about with these, with the milkfish from last week, as well as these carp and the next couple families we have orders we have to talk about. So these kind of help with the swim bladder and the inner ear, so they can kind of perceive sound waves through the water a little bit better, because the air bladder acts as like a amplifier, if I'm remembering correctly.
Okay. Yeah. Yes, kinda. It's like it's like a structure off of the swim bladder.
Yeah. However, they do differ from these other groups that I was mentioning, the slower forms and things like that, because they only have a dorsal fin on their back. A lot of these other species have like a type of adipose fin around their caudal fin. And they also have this unique structure called a kinethmoid, which helps in the protrusion of the jaws. So it's hard to describe. It's kind of similar to the pharyngeal jaws of the
Morays.
yes, those. But it is a midline size sesamoid bone that develops within the tendon running from the premaxilla to the neurocranium.
So that'd be like the front of the mouth to like the front of the like actual skull, basically, like from the mouth bone to the skull bone, first skull bone, right? Of the upper
Yeah.
jaw. That's
Yeah.
that's your maxilla is your
And how
upper
this
jaw.
works is it's able to rotate around the maxillae, and it pushes the premaxilla forward.
Okay. So it kind of helps him, gives him very pouty lips, is what it does.
Yeah.
Okay.
Another unique thing about these guys is they lack teeth in their mouth, which is odd to say, but they have pharyngeal teeth that they kind of use, similar to, like, I almost compare it to the radula of a snail,
Okay.
where it uses it as like a grinding pad. Like they grind these teeth against a chewing pad on the rather than the upper jaw. So rather than like chewing, they grind their food up like sandpaper, like rubbing against sandpaper.
Okay.
And they are believed to have diverged from the track forms in the early Triassic. So this would be splitting off from like piranhas in the early Triassic. But it's also plausible this might have happened later on in the Jurassic period when Pangea split.
Okay.
Alex, would you like to cover the suborder Gyrinochelloidae? This is going to be our first suborder for the day.
Yes, sir. So this suborder contains a single genus, Gyrochaleus. They're known to live in fast-flowing mountain streams, so very like headwater streams, commonly known as algae eaters. So you see these a lot. Or I shouldn't say a lot, but you see them sometimes in aquarium. They have a very sucker-like mouth, as you can see in the image I pulled up. Lets them hold on to objects, feed on a lot of detritus. Kind of they scrape algae off of the rocks, or if you have them in a fish tank, off of the walls of the fish tank. Typically, they stick to the bottom of the stream where the sediment is able for them to cling to. They also cling to algae and wherever the food is most readily available, such as in a fish tank on the sides and tops of the tank. They have gill slits that possess two openings, one for entry and exit, so it allows the fish to breathe without the use of its mouth, which is a little different. Typically, fish kind of leave their mouth a little bit open, or they'll kind of gulp with their mouth, pumping that water across the gills. The Gyrinochellius amoneri is sometimes used in aquarium, but it is known to be somewhat aggressive, so it's not a great tank mate, especially for very docile fish. And if they are improperly fed, they rip the scales off of other fish, which makes those other fish prone to infection. Gyrinochellius pinocchi is also known as the spotted algae eater, and that is endemic to the waters of the Mekong, which is, where's that, in China?
No, Vietnam.
Vietnam, okay. And then the Borneo algae eater, Gyrinochellius pustulosus, differs from those other members because it has 10 dorsal rays, so the kind of spines in the dorsal fin. It has 10 of those instead of 9, and it has up to 40 vertebrae. Typically, you don't see that many.
Yeah, the other two species have 36 to 38 vertebrae
Okay.
each. So they're a bit like extra boned, per se.
They're big boned, you could say.
So
Except
next is
they,
going to be. Go ahead. What were you going to
I
say?
was just saying, yeah, you could say they're big boned, but they're
They're
actually
big
quite
boned.
small.
Yeah.
They don't get very big.
No, they don't. Probably around 11 inches, I think, is like
And that'd be a big one, yeah, because of those headwater streams tend to not be very deep.
Yeah. But that'll move us over into our second suborder for the day. This is gonna be our last suborder for the day. Catastomoidae. These are the suckers. That's a good sucker.
This is a good sucker. It's the white sucker.
White sucker.
Yes, sir.
There's about 80 species found in this suborder, almost exclusively in North America. However, Catastomus is native to both Russia and America, and the species Cyprinus asiaticus is found solely in China. Some areas, specifically the Ozark region of North America, so that's what, like Arkansas,
Missouri, kind of
Missouri,
that western side of the
the
Mississippi.
South Midwest.
Yeah, like
the
but
easiest way to put it, I guess.
pretty much, yeah, like South Central Midwest is kind of a good way to put it, or like the northwestern South. I know it's funky to describe that to our non-American.
Dead center.
Pretty much, yeah, very central to the United States.
They actually use suckers as a common food fish. They even have an annual festival for them, which I think is pretty cool to have a festival dedicated to these little sucky boys.
Mm-hmm.
They have subterminal mouths, which means that the mouth is found below the snout in most species. As you can see in the picture, the fleshy like mouth is at the bottom of their head, not at the terminal point. And they have very thick lips to help with their sucking. Most species are less than 2 feet long. However, there have been some known to be upwards of 3 feet. Most commonly found in the river systems of America. However, they can inhabit all freshwater systems from lakes to ponds to little tiny streams and everything in between. And they eat a variety of things, from detritus on the bottom to living crustaceans, insect larvae, even surface insects like the water striders, terrestrial vertebrate, and even other fish. Kind of confused on how it eats. I'm sure it eats like squirrels.
Now, I would guess more like salamanders.
Oh yeah, those are vertebrate.
Frogs, yeah.
Those are vertebrate, yep.
Yeah, even though they're amphibians, they are technically terrestrial vertebrates.
Forgot about that a little bit.
Yeah, well, semi-aquatic.
These guys separated from other Cypriniformes in the Eocene period, is what I think. I think it's properly called a period. There's like epochs and periods and
eras
and things like that.
Yes.
The Eocene, during the Middle Eocene geological time period. So we'll move on into our genuses now. There's a doozy number of genuses here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 genus to cover.
Jeez, yeah, so we better get a rolling.
Yeah, we're gonna start trucking along here. The first genus, Catastomus,
which is what is pictured currently.
Yeah, this is one of the larger genus in this group. We got the Catastomus. Well, first off, before I get into the individual species, these guys have cylindrical bodies, as you can tell, large horizontal mouths. So rather than a vertical opening, it's horizontal, like most mouths are. I don't know why you'd have a vertical mouth.
Well, it'd be more like a circular mouth you would expect, since they have like that sucker kind of.
So it's more square. It's more ovular than circular.
I would assume so.
Complete lateral lines. which is the lateral line, is that electroreceptor system that goes along the middle part of the fish, and it helps with receiving electrocurrents through the water.
And vibration, yeah.
It's an extrasensory organ they have,
Yes.
in simple terms. And they have that two-chambered gas bladder. They have 28 species in this genus. Catastomus ardens, which is the Utah sucker. The Catastomus bernardini, which is the Yaqui sucker. Catastomus bondi. Catastomus cahida, the Cahida sucker. The long-nosed sucker is Catastomus catastomus. Catastomus clarkii is the desert sucker. The bridge-lip sucker is Catastomus columbianus. The white sucker, Catastomus commersoni, as pictured. The Matalote conchos is Catastomus conchos. That one's found solely in Mexico. Catastomus discobulus is the bluehead sucker. Catastomus fumiventris is Owen's sucker. The Sonora sucker is Catastomus insignis. Catastomus latipinus is the flannel mouth sucker. The Bavispe sucker is Catastomus leopoldi. Catastomus macrochelius is a large-scale sucker. The Modoc sucker is Catastomus microps. The Nasus sucker is Catastomus nebuliferus. The Sacramento sucker is Catastomus occidentalis. The mountain sucker is Catastomus platyriensis. I've seen pictures of them, and they look pretty funny, actually.
Okay. Let's see if I can find one for us. If I can find a good one.
If you click on it in the notes, it has a picture.
I know, that's what I did. Give me a second. Here you go.
The Rio Grande sucker.
They're kind of funky looking.
Catastomus plebeius. They do look kind of funky. Yep, that is your mountain sucker. I think it's just the face.
I believe, yeah,
it looks very hippo. I lost my place now. Oh, Catastomus plebeius is the Rio Grande sucker. The Klamath small-scale sucker is Cladostomus ramiculus. The Santa Ana sucker is Cladostomus Santa Ana. The Klamath large-scale sucker is Catastomus snyderi. Catastomus tahoensis is the Tahoe sucker. Catastomus siltcucensis.
There you go.
That's the Tai sucker. That was actually pretty good.
Yeah, it was real good.
Catastomus utawana is the summer sucker. Catastomus warnerensis is the Warner sucker. And last but not least, the Apata sucker is Catastomus wigginsi.
Nice.
Would you like to cover the next genus out?
Yes, sir. I already got a picture locked and loaded. All over it today. Next genus is...
That's a kiwi.
It is. Next is the... actually, I believe those are short-nosed suckers.
Are they?
I believe so. So the next genus is Chasmistes. They are native to the western United States. Most species are listed as threatened on the IUCN Red List, which is where our amazing species come from. They have, as you can see in the picture, large, stout bodies with very large heads and kind of humped snouts. The one fish you can see kind of in the front center, you can see that snout is very kind of bulbous. Kind of got as it says, that kind of humped shape to it. They do have those complete lateral lines and the two-chambered gas bladders, but they will have either subterminal or terminal mouths. So they can have either your typical end of the snout mouth, or they'll have the subterminal under the snout mouth, as many of these other ones do. There are 5 species in this genus. Chasmistes brevirostris, which is the short-nosed sucker, which I have pictured here. Chasmistes cuhus, which is the kiwi. Chasmistes fecundus is the wee bug sucker. Chasmistes leoris is the June sucker. And Chasmistes muriae is the Snake River sucker.
Hold on one second. Okay, yeah, I was right. This Snake River sucker is extinct, but it's recent enough that we decided to cover it in our lesson day because it went extinct within the realm of recorded taxonomy.
Oh, okay.
So it went extinct in the 1920s, I believe.
Oh, okay.
Yeah, 1928. It's a good picture though. That's a lot of suckers.
It is a lot of suckers.
That'll move us into our next genus. Deltistes. There is one surviving member, Deltistes luxatus, which is known as the quam. They are found solely in California and Oregon, and has a greatly reduced range and population compared to its historical numbers. So they used to cover a wide area, and then humans kind of came along and said, we're going to build dams and do all this other cool stuff, and they just kind of tanked. They are listed as an endangered species by both the IUCN as well as the Endangered Species Act. Unlike some of the other species we've covered today, they like these deep lakes where they can kind of hide in the bottom, as well as areas with high concentrations of vegetation. They spawn in the springtime and lay upwards of 200,000 eggs and are able to spawn several different males, or rather, several different males fertilize one clutch of eggs. And as I said, over 70% of the original range of the species was impounded and drained. Other threats include dams, as well as a lot of introduced species, not necessarily like invasive species, but introduced from other areas of the U.S., like pumpkin seed, brown trout, bluegill, popular sport fish that we bring in so that anglers can, have good competitive fights with fish, and then we don't really think about the native species.
Yeah. We have a problem with that.
Yeah, which is a common occurrence for a lot of the things we talk about, especially in the world of fish.
Yes.
Is this one doesn't fight back enough, so we're going to introduce things, and then it just gets outclassed and goes endangered.
Yes. Unfortunate.
We'll move on into our next genus, Alex.
Yes, it is Iramizon, which are also known as the chub suckers. These are also native to North America, found in creeks, lakes, ponds, streams, rivers, primarily near thick vegetation. Diet consists primarily of aquatic insect larvae, so probably in slower moving areas where those larvae, or like some of those deeper pools where those larvae are able to kind of congregate and survive. There are 4 recognized species. You have Iramizon claviformis, the western creek chubsucker; Iramizon oblongus, the eastern creek chubsucker; Iramizon suceta, the lake chubsucker, which is what I have pictured here; and Iramizon tenuis, which is the sharp fin chubsucker. I think I have a picture. I do have a picture for the next one. It's pretty short, so I'll just run right into that. Our next genus is Hypentelium. These are recognized as the hog suckers. Let me find this guy real quick.
Switch.
Go. Found primarily in the eastern United States and southern Canada. We have 3 species. Hypentelium etuanum is the Alabama hogsucker. Hypentelium nigricans is the northern hogsucker. And Hypentelium roancens, which is the Roanoke hogsucker.
So that'll move us into our next genus, Minitrema. There's one single species in this as well, Minitrema melanops, which is the spotted sucker. They get that name because they have a dark spot at the base of each individual scale. They can reach up to 19 inches, and throughout its lifetime, it'll go. Well, they're found throughout most of the central and southeast U.S. as well as southern Canada, and can be found in most of the Great Lakes as well as the Mississippi River Basin. Throughout their lifespan, they go from a mid-level, like mid-water level predator to a bottom feeder forager. That's all I have for that one. I'll cover the next one as well, since that one's really short. Moxostoma. This is our second biggest genus we've talked about. They're known as the red horses or the jump rocks. They vary greatly in size, range, and other traits, and those traits could be anything from the sediment they lay their eggs on, to their diet, to like water temperature preference. That being said, a lot of these species are very intolerant to any type of pollution or fragmentation, as well as they're under heavy, I don't want to say poaching threat, because it's not really illegal, but the recent surge of bow fishing Alex, I don't know if you're probably more familiar with bow fishing than I am. But
A little bit, so it primarily has to do with basically use a compound longbow, which the arrow has a specific type of tip and like a fishing line attached to it, and you basically shoot the fish and then reel it in.
yeah, so there's not a lot of like laws and regulations to it yet. It's a rather new practice, right?
It's not super new. There are some laws and regulations, but not as much as regular fishing.
Right. Like I'm sure there's still like bag limits and catch limits and stuff like that, but I'm not sure. But these guys are under heavy pressure from bow fishing because yeah, it's just a thing that happens. I don't have an exact reason for you. I'm sorry. But we got 22 species. The Moxostoma albidum, which is the long lip jump rock. Moxostoma anicerum, the silver red horse. Moxostoma areomum, the big eye jump rock. The Mexican red horse is Moxostoma ostronum. The smallmouth red horse is Moxostoma breviceps. Moxostoma carinatum is the river red horse. The black-tipped jump rock is Moxostoma cervinum. The notch-lip red horse is Moxostoma collapsum. The gray red horse is Moxostoma congestum. The black red horse is Moxostoma duquesne. The golden red horse is Moxostoma erytherum. Yeah, no, I'm connecting dots in my head that might not be actual dots to connect.
Okay.
Because I'm connecting a erytherum to erythromycin.
Yeah, and that's not kind of. I don't know if that's a dot
And
to
I'm
connect.
not sure if that's a dot I'm supposed to be connecting.
I don't think so.
I'll figure it out later. Anyway, continuing. Moxostoma hubsy is the copper red horse. Is that what you pulled up? I was.
It is not.
Oh.
And you could think so, but that is not.
It's pretty copper color.
It is.
The greater jump rock is Moxostoma lacneri. The short-haired red horse is Moxostoma macrolepidotum. Mascota jump rock is the Moxostoma mascote. There's Moxostoma milleri. Moxostoma papillosum is the V-lip red horse. Moxostoma pisolabrum is the P-lip red horse. Moxostoma
Posiliarum.
Yeah, the black-tailed red horse. The robust red horse is Moxostoma robustum. Very
As
descriptive.
pictured.
Oh, very, very robust.
Yes.
The striped jump rock is Moxostoma rupescardus. Moxostoma valencianus is the greater red horse. And that's all for the red horses or the jump rocks.
Okay. Very cool. I'm trying to pull up pictures for the next two groups, just because they're both kind of small.
Those dots that I was talking.
Yeah, I didn't think so. So next up, we have the genus. It's a small genus, Thoburnia. Oh, there's a picture off of iNaturalist.
Good job, community biologist. Whoever published this.
Yes, it is this genus of suckers is found in the eastern United States. It was formerly a subgenus of Moxostoma, which we just talked about. There are 3 species in here. We have Thoburnia atripinus, the blackfin sucker, which, as you can see, is pictured here. Thoburnia hamiltoni, the rusty side sucker, and Thoburnia rothoca, which is the torrent sucker. Our next genus is a monospecific genus. It is Xyrauchin. Let me pull up my picture here. There we go. From Nevada Department of Wildlife.
They're cool.
They're
one
cool
of my
looking.
We talked about.
Yes, it is the razorback sucker, Xyrauchin texanus. It's found in lakes and rivers in the southwestern United States and Mexico. They can grow up to 3 feet long, and as you can see in the picture, they're highly recognizable due to that keel, which is that kind of big hump between the head and dorsal fin. They have become critically endangered due to damming and habitat loss of the Colorado River Basin. There are some individuals that are believed to be upwards of 40 years old, so they live quite a while for fish. And they habit a variety of habitats from mainstream river channels like the Colorado River to backwaters of small to medium streams, which is where the basin comes in, the river basin. That may be something we can talk about as an ecology encyclopedia in the future. Yeah. And then we have a couple more small genus. If you want to go to those, I will pull up pictures.
Yes. We are moving on to. So I tried to make a new tab for next week's episode, so we didn't forget about our ecology encyclopedia, and then I lost my track here. But I remember where we're at here.
We're
We're
on
at
it.
Cycleptis.
Yes, sir.
Cycleptis is endemic to the river basins that drain into the Gulf of Mexico, which in other terms is the Mississippi River Basin and the Rio Grande River Basin. They're relatively large, over 4 pounds, and about 30 inches on average. Like, as you can see in the picture, the guy's holding it with 2 hands. I don't hold most fish with 2 hands. I hold my little bluegill up with 1 finger. But there's 2 species in this genus, Cycleptis elongatus, which is the blue sucker, and Cycleptis. Whoopsies, I done goofed. I put the same name twice. Oopsies. Oopsie. Cycleptis meridionalis is the southeastern blue sucker.
Okay. The picture here is just the blue sucker, Cycleptis elongatus.
That'll move us on into our next genus, Carpiotis. This is the genus with a long hook-shaped dorsal fin. These are called carp suckers, by the way. They have a very carp-like body form.
They do?
There's 3 species, but they're also silver-bodied with orange pelvic fins, as you can see in the image. Nice shiny silver body. And kind of pinkish-orange dorsal pelvic fins, not dorsal fins. 3 species included in this genus are Carpiotis carpio, the river carp sucker, Carpiotis cyprinis, which is the quillback, and Carpiotis vilifer, the high fin carp sucker. I'm going to take a guess and say this is the river carp sucker.
This is the quillback.
0 for 2.
0 for 2. It's okay.
Would you like to cover the next genus?
I can do that. The next genus is Ichthyobus. Yeah, sorry, I was making sure I was in the right spot. I apologize. Which these are the buffalo. Let me zoom in on my picture here a little bit that I found. So these are all commonly known just as buffalo or buffalo fish. They are found throughout the United States, Mexico, and even down into Guatemala, so central parts of Central America. They're the largest and most long-lived suckers, reaching 100 years old and over 4 feet in length. They were not previously popular game fish because they're difficult to catch on a fishing rod and fishing line, but there are new techniques that have caused a surge to these, primarily bow fishing that we talked about, which has made them a very prominent sport fish in their range, but that has caused a dramatic population loss. So while it's become more popular to fish these, and specifically bow fish, which unfortunately there's no way to release a fish that was caught through bow fishing because you shoot the fish. These fish, if you eat the meat of these fish, it is there's been a few cases, I think 8 cases of what is called HAF disease, HAFF disease. This causes a swelling and breakdown of the skeletal muscle and can cause a risk of acute kidney failure. So do not eat these fish.
One thing to note is this isn't the only carrier of the bacteria that causes HAF disease. There's other cases that are due to like salmon and pike, and there's other cases in China due to a crayfish outbreak.
Okay.
An outbreak from crayfish.
Okay. But we have 5 species in this genus. We have Ichthyobus bubalis, which is the smallmouth buffalo, Ichthyobus cyprinellus, the bigmouth buffalo, Ichthyobus labiosus, the fleshy lip buffalo, Ichthyobus meridionalis is the Usumacinta buffalo.
That one's found in Guatemala.
Okay, and Ichthyobus niger, the black buffalo, which is what I have pictured here.
Yeah, the normal, like the smallmouth and bigmouth buffalo are the two most common ones, and they're a nice, brilliant silver color.
Yes. And I believe this one, the black buffalo, I believe this is the largest one.
No, the big mouth is.
Is the big mouth? I was trying to find a picture of a really big one so that way to show it off.
Yeah, I don't know how true the hard to catch on traditional rod and line is, because I remember playing video games with you in college, where we'd sit at a lake and fish, and that was the only thing I catch is buffalo.
Yes, but that's a video game.
Well, yeah, I haven't been to Texas to catch buffalo. I'd love to.
Me neither, buddy. Me neither. That'd be cool. Sounds like a little trip that we should take.
Yeah, sure.
Yeah.
Sure.
Yeah. Yeah. But then this will take us to our last genus for today.
Mixocyprinus.
Yes.
Mixocyprinus is unique in that it is it's monotypic. It is solely containing, I don't even have the name.
Mixocyprinus asiaticus.
That one. It's the only species found in Asia. It's specifically found in the Yangtze River of China. Hence why it's named as the Chinese sucker. It is distinguished by a brownish body with 3 dark-colored slanted bands. This is a juvenile Chinese sucker. I couldn't think of the name for a second. The adult males get a more reddish color, while the females are more purple. I'm assuming that's their slants. I think it keeps the brownish body and gets this colored slants.
Okay.
And the juveniles have a very tall dorsal fin, and as they age, that dorsal fin becomes less prominent, or less heightened, I should say. But that's going to do it for our lesson for the day. Our meat and potatoes have been covered. We'll move on into our routine segments.
Yes, sir. Where do you want to go first?
Up to you, brother.
Well, I already have a picture pulled up, so we will go with my most wanted for this week, which is I was good. I found one on topic this week. It is a Cypriniform. It is not one that we talked about today, though. The fish I found today is the tench. It is a scientific name, Tinka tinka. It is
What?
it is, as I said, in the Cypriniformes. They were introduced into parts of North America as a fish. It's indigenous to Europe and Western Asia, brought to the United States and other parts of North America in about the 19th century as food and sport fish. They were brought more specifically to Canada in like the mid 1980s to farm them, but they escaped, and they are very adaptable. So they have invaded pretty much every corner of the planet but Antarctica, and they cause a lot of damage in those areas that they have invaded. This olive color competes with a lot of native species like minnows, bullheads, and suckers because it eats a whole lot of snails and insect larvae, which, as we talked about, these are things that these native species tend to eat a lot of. And because of that, it eats those suckers and minnows, as well as the insect larvae. It kind of promotes algal blooms, which, as we've talked about in the past, can become very bad because while there's a spike in oxygenation in those areas when the algae blooms, as it dies and that breaks down, it creates a very oxygen poor area, almost like a dead zone. As I said, they have these bronzy olive colored scales with those reddish orange eyes. And they have small scales, and they really don't have spines on their fins, which is why they're very popular sport fish. They're probably easy to catch and release. There's sometimes the juveniles are confused with some other bait fish species and carp, which is kind of why they can spread fairly easily because they're misidentified. So fishermen will release them back into the water. As we said, they outcompete a lot of those native minnows, bullheads, and suckers, eating a large quantity of the same food, causing that disturbance. But they also have a tendency to increase a lot of parasites such as cestodes and copepods, so like tapeworms and little crustaceans, especially to a lot of other cypriniform style fish. And then that then leads to fish eating birds contracting tapeworms, and it affects the local waterfowl populations as well, not just the fish populations. And it has been seen to be a reservoir to the rhabdovirus, which causes a viral infection of the bloodstream and carp, and causes is kind of contributing to some outbreaks of those diseases. And they are bottom-dwelling fish like a lot of the other cypriniforms, which is why they outcompete those red horses and suckers.
Gotcha.
That
That's
is
interesting.
yeah, that is the biggest things I have on the tench as far as why they're considered invasive, and because of that as well, since they outcompete some of those other bait fish and bottom dwellers, they kind of impact the ecosystem as a whole, not just the small invertebrates and vertebrates that they eat, but as it goes up the food chain and kind of impacts those sport fisheries as well.
All right, so that'll move us over into our amazing species for the day. As always, this is the segment where we cover a species noted on the IUCN Red List as threatened or vulnerable or higher on the IUCN Red List. We try to stay away from the least concerned or data deficient. And Alex's previous session that he just covered was his most wanted, where we cover an invasive species, typically North America. But once we run out of those, we'll cover other areas of the world.
We'll do our best at least.
Until we run out.
Yeah.
But today's amazing species is the kiwi, or the kiwi, Chasmistes cujus. Most recently assessed in 2011, Chasmistes cujus is listed as endangered. These guys are found in the, I don't know what to call this.
Like the Sierra Nevada kind of.
Yeah, and the Sierra Nevada Mountain regions, like around the regions of Reno, Nevada.
Yeah, so
per se.
Kind of northeastern California and northwestern Nevada, kind of crossing the state line around the whatever river that is.
Yeah.
The Feather River. There's a lot of areas. There's a lot of near Tahoe National Forest and kind of north, so north of Lake
Pyramid
Tahoe.
Lake.
Yes.
But these guys are actually increasing on their population trend.
That's something you don't see too often. That's fantastic.
That is a big plus. Yeah, as I said, these guys were assessed in 2011, published in 2014. These guys in 1996 were originally listed as critically endangered.
Okay.
So now we're up to endangered, which isn't a big jump, but it's a big jump. So we're listed endangered because the area of occupancy is less than 500 square kilometers, and it occurs in that sole location, which is this one watershed, water basin type thing.
It is considered an endemic species.
Yes.
There we go.
Yes. Which means that it's subject to extreme fluctuations over a multi-year period. They are a full migrant movement pattern, though. So their typical habitat includes lake areas with shallow sandbars and stuff. And they try to avoid deep water areas where there's that steep drop off. They spawn in the Truckee River. So I guess that's what their range is more of it likes to live in the specifically Feather Lake, but it spawns more in the Truckee River. Although there are some cases where spawning does occur in Pyramid Lake. But due to high alkalinity and elevated salinity, there's very little successful reproduction in those areas. So they have some threats to them, most notably natural system modifications, which would be dams or other water management insertions, as well as pollution from domestic wastewater, industrial effluents, and agricultural effluents. So fertilizer runoff, industrial runoff,
yeah,
as well as human wastewater, groundwater.
Okay.
Not much is in the use and trade. It used to be intensively fished, not so much anymore. Endangered Species Act kind of put a ixnay on that one.
Yeah.
We do have the Action Recovery Plan, as well as its entire range is a conservation site.
Fantastic.
And that will lead us into our final segment of the day.
Yes, sir.
Alex, you picked a good one.
I did pick a good one. So today we are talking about something that's we've talked about a little bit, but I just wanted to cover it in more detail, and that is the predator-prey relationship. So, or also known as shown in this graph, the predator-prey interactions. So, kind of give a short little synopsis, a little definition. So, a predator is an organism that eats another organism. Now and the prey, of course, is whatever that predator eats. Now, this, as shown here, like wolves and rabbits is one example, but it's not just animals eating other animals, although that is kind of a common misconception. It does apply to plants. So the rabbits that are indicated in the model here eating lettuce, technically the rabbit is the predator and the lettuce is the prey. So it's a very general term to kind of explain a feeder and food relationship. But the graph is what I really wanted to cover with this. It's showing that interaction, that relationship. So you can see the wolves are in orange, that is your bottom line, and the rabbit population. So this is your populations over time, over generations. Your rabbits are your blue line, which is your upper line. And as you can see, the fluctuations in population sort of follow each other. So as the rabbit population increases, so shortly thereafter the wolf population increases because there's more food available. But once you get to a certain point with the wolf population, the rabbit population then starts to crash because there's way more predators eating way more prey, and then that drops that population, and it reaches kind of a critical point where you get too many predators and not enough prey. So then some of those predators don't have enough to eat and they die off, causing a crash of the predator population. And then with that, there's less predators. The prey is able to recover and increases population again, and the cycle continues. This is seen in typical healthy predator-prey relationships. Now, there are some, when we talk about invasive species, this model changes where you'll get the predators, like we talked about the tench eating those snails. Excuse me. The tench population will just skyrocket because the tench doesn't have predators, and the snail population just takes a nosedive, and that's kind of the danger of invasive species. And this, as it goes, you go up the trophic levels, you see a lower number of predators because your predators tend to get larger. They require more food, so they have to kind of have a more diverse food source. But because they larger and require more food, you can't have as many of them, which is why. And this is just in this one area. You can see the rabbit population at its highest gets almost to that 160, 180 range, whereas the wolf population doesn't get much higher than the 120 range. So you're going to see a lot more prey than predators, because if you don't have enough prey, you don't have enough predators, which is why it shows a cyclical relationship. But over time, you can see kind of that overall increase in both the predator and prey, that kind of the peak populations will go up, but then the valleys get lower, so you kind of get you'll get bigger peaks and valleys over time, and then eventually it gets to a point where that will have to level back off again, and then as the prey's food becomes overeaten, so the rabbits will overeat the vegetation as those peak numbers begin to increase, and that's where the other part of why the population crashes is also in there, and that's why the rabbit population will crash first, because it'll eat its food source, and then as more rabbits are eaten, you see the increase in the wolves. But that's all I have for that.
Not necessarily it'll crash first. There's top down and bottom up. population crash. Like if you take, it's based off of what you take out of it. But like if you just let it run naturally, yeah, it typically is a bottom up.
True.
But in the this is a bad example because wolves are hunted heavily because you're taking out the wolves out of this, which means that the rabbits will spike, but then they'll eat all of their food. So it's a weird thing.
Yeah, a typical kind of what we would consider environmentally healthy predator-prey relationship would be what is shown in the model, where your prey will increase, and then following your predators will increase, and then as your predators reach kind of a peak point where there's enough predators for the amount of prey, the prey will then level off and start to dip down as the predator population increases. So it kind of follows right behind it. But as Tyler said, not always, but those cases are a little fewer and farther between than these types of cases. Typically, the predator populations will follow after the prey populations.
Yeah, in a healthy, stable, neutral, environmental type of relationship, yeah, this is your typical. But whenever there's outside interaction, there are atypical.
Correct, because typically a prey species does not have just one predator, and predators don't typically have one prey species.
You can get really funky when you're doing like a graph like the picture that we have and overlay multiple species
Yeah.
and see how they all interact. Because you could easily say, oh well, the rabbit is the wolf's like primary food source, but when obviously when the rabbits are low, it has to eat something else.
They start eating like squirrels or chipmunks or whatever else.
So then you can overlay that.
Yeah.
And you can see the
there's
hills and valleys of like 6 different species. Then it gets to be a confusing mess of lines.
Yes.
But that's your problem for making it that big.
Yes. But
that's why for simplicity's sake we've covered 2 in this. But we're rambling at this point.
Yeah.
So we're gonna wrap it up for this week, ladies and gentlemen. As always, I have been Tyler with my co-host Alex. We have provided you a wonderful episode on the start of the Cypriniformes. Is that the proper term?
The Cypriniformes.
Next week we will cover the loaches, followed by the following week the carp, and that'll cover all 3 major groups of Cypriniformes. Just to give you a little roadmap. As always, you can follow us on Instagram at Life Complete Story. Follow us on TikTok at Life Complete Story. There you will have weekly reels, TikToks, short form content of the episode. Typically, we highlight 1 or 2 little bits from our episode each week. Follow us or subscribe to the page at YouTube, Life the Complete Story. We have backlog of all of our episodes in video form. They're also in video form on Spotify at Life the Complete Story, but it's really user preference at that point. YouTube also gets our reels, our short form content each week. Follow us on Facebook at Life the Complete Story. You'll get extra news articles on there whenever we find something interesting, cool, what have you. Send us an email at lifecompletstory@gmail.com, where we always like to hear your feedback, something you want, something you like that might not fit in our comment section or whatever has you, or it's more private, something like that. Am I missing anything?
No, I think you covered it all.
Awesome.
Good job. Yes, sir.
So we will see you all next week. As always,
keep learning, learn something new. You never know what you'll find interesting. But as said, I've been Alex, that's been Tyler. Thank you for joining us this week on Life the Complete Story. We'll see you next time.